Have you ever been asked in an interview to find the closest points to a location? Today, we are going to solve one of the most commonly asked Leetcode problems called K closest points to origin. It's a favorite among technical interviewers because it tests your skills with heap, sorting, and distance calculation. So whether you are prepping for an interview or just brushing up on algorithm, this video is for you. So without wasting any time, let's get started. Alright, now let's go over the problem. We are given a list of points in a 2D plane xy, where each point is represented by xy coordinates, and we need to return the k closest points to origin. The distance between 2 points on a plane is calculated using Euclidean distance, and this is the formula to calculate the Euclidean distance between 2 points. And finally, we will return all those points, but we can return them in any order, and the answer is guaranteed to be unique. Let's break down the Euclidean distance calculation here. For a point xy, the distance from the origin is calculated by square root of x square plus y square. However, we can simplify things here to improve the performance of our solution. Instead of calculating the square root, which is relatively a costly operation, we can work with square of distance x square plus y square only. This way, we avoid unnecessary competition, which can speed up things. To make sure we are on the same page, let's look at an example. Suppose we have 3 points. For first point, x is equal to 1 and y is equal to 3. For second point, x is equal to minus 2 and y is equal to 2. And for third and last point, x is equal to 5 and y is equal to 8. We are asked to return the 2 closest points to the origin. For this, we would calculate the square distance for each point. For first point, 1, 3, the square distance will be 10. For second point, minus 2, 2, our square distance would be 8. And for third and last point, 5, 8, this value of the square distance would be 89. Since we only need 2 points, 2 closest points, so our answer will be first point 1, 3 and second point minus 2, 2 with the square distance of 8 and 10. Third point, for which x is equal to 5 and y is equal to 8, is further away with a square distance of 89. So it is excluded from our result. Now let's get into the solution approach. There are few ways to solve this problem, but today we will focus on a method that uses a max heap for efficiency. This approach is optimal because it allows us to keep track of k closest points without sorting the entire array, which would be extremely slow. So here is the plan. First, we will initialize a max heap that will store the pairs of distance and points. Next, we will iterate through each point and calculate its square distance. Then, we will maintain the heap size to k by only pushing points that are closer than the furthest point in the heap. Finally, we will extract the remaining points from the heap and return them as a result. Okay, now let's start coding our solution. First, we create a max heap using a priority queue. As we loop over each point, we calculate the square distance and push it into the heap. We are storing pairs where The first element is the square distance and the second element is the point itself. This way, the heap will order points by distance in descending order. If the heap exceeds size k, we pop the furthest point. By the end of our loop, our heap will contain only the k closest points. Finally, we extract the points from the heap, store them in our result vector, and this gives us the desired points in no particular order. And that is our result. So we can simply return it back. Okay, now let's try to run our code. As you can see, all the test cases are successful. So if we will submit the code, we can see that it's a very efficient solution to our problem. I will also attach a link to this code in the description box. Now let's talk about the time and space complexity. This approach has a time complexity of O of n log k, where n is the number of total points and k is the number of closest points we need. That's because each insertion and deletion operation in the heap is O log of k, and we do this n times. In terms of space complexity, the priority queue stores up to k point, so we have a space complexity of O of k. Alright, that's it for today's tutorial on the k closest points to the origin problem. We covered how to solve this problem using a max heap, and we discussed both this time and space complexities. I hope you found this explanation helpful. If you enjoyed this video, please give it a thumbs up and subscribe for more coding tutorials. And let me know in the comments what problem you would like to see next. Thanks for watching.